Hi everyone, this is Mrs. Eggerding, and you're watching the last video for Unit 3, and we're going to talk about quadratic inequalities, the greater thans and less thans with these quadratic equations. Now, before we do that, I want to talk a little bit about how you solve, just remind you, how do you solve a linear inequality? So we go ahead and we normally subtract 5 and divide by 4. And if I were to divide by a negative number here, I'd have to flip the inequality. What I divided by 4 was positive, so I'm okay. The inequality then is x is less than negative 1, which we can also graph with an open circle at negative 1 and then going to the left. And then we can also write that in interval notation. So negative infinity to negative 1, open brackets all around. What we want to do now, though, is take that solution and say, okay, what does this look like in a coordinate plane? So in other words, instead of having one dimension, one number line, what happens when you have two? And what that's going to look like is I'm going to take the left-hand side, the 4x plus 5, and I'm going to graph that. So we have a y-intercept of 5, slope of 4, 1, 2, 3, 4, 1, 2, 3, 4 over, and we get a line that looks like this. I can then take the right-hand side of the equation, the 1, and draw a horizontal line at that for that. Now what you might notice right away is that the intersection of these two, the intersection is this negative 1. So that negative 1 is the intersection that we've created here. Alright, well what about the less than? Well, if I want to talk about when this red line is less than the green horizontal line, I'm talking about when it's below. And it's below everywhere down here. So this is where the line 4x plus 5 is less than a y value of 1. Now if I were to describe all of the x coordinates that makes up, all of these x coordinates are from the negative 1 and they continue going left, just like we found. So it's taking something that's in one dimension and we're spreading it out a little bit differently. So let's continue looking at this on the coordinate plane. Let's see what some other ones look like. So we're going to solve this inequality graphically. I'm going to start by graphing the left-hand side, so negative 2x plus 3. You know what? Let's keep the blue. So there's my y-intercept, a slope of negative 2. And I'm going to get a couple of good points. And so there's that. I now want to graph the negative 1 as a horizontal line. There's my negative 1. There's my horizontal line. So let's notice a couple of things. First of all, I'm going to look for this intersection, and specifically I'm going to look for the x-coordinate of that intersection. And in this case, I get x equals 2. Next, I want to compare when the blue line, so when is negative 2x plus 3, and because it says greater than, when is it above the negative 1. And if I look, it's everything on this side. So the negative 2x plus 3 is above because that's what the greater than is on that part of the graph. Okay, so now what I need to do is I need to describe those x-coordinates that I just shaded, and they are from negative 2, and these numbers are going to the left. So I know my solution is negative infinity to 2. If we go ahead and try to solve this, algebraically, subtract 3 from both sides, I get negative 2x is greater than negative 4. Divide both sides by negative 2. I have to flip my inequality because I'm dividing by a negative, and I get x is less than 2, which is exactly what those x-coordinates are described. And so what we're going to have you guys start practicing here is looking at a graph of a quadratic. And can we solve these inequalities just by looking at this graph? So here's a function f of x. I want to know when it's greater than 0. First thing I'm going to determine is I'm going to find out where it equals 0. And in this case, I have two places where it equals 0. X is negative 2 and x is 1. Second, I'm going to find where, in this case, the graph is above 0, or in this case, above the x-axis. This one's going to be above the x-axis. That means these y-coordinates are all greater than 0 in that region. And then the last thing you're going to do is to write the intervals of those x-coordinates. And so on the right, the x-coordinate starts at 1, and these x values get bigger, so 1 to infinity. On the left, the x-coordinates start at negative 2 and get smaller. So we're going to write that as negative infinity to negative 2. Let's try the same graph, but this time let's talk about where it's less than or equal to 0. So this means I want to know where the graph is below, and then 0 means it's below the x-axis. Okay, so same steps. First of all, I want to find where it equals 0, negative 2 and 1. Next, I want to find where is it below the x-axis. Below because it says less than. And that's all. That's that part of the graph. Last thing I want to do is I want to describe the intervals, or in this case, one interval where this happens. It starts at negative 2. It's using all of the x values in between here until it stops at 1. I'm going to close these brackets because I want to include it's less than or equal to. The or equal to gets a closed bracket. Here's a new one. So we have a different graph, function g, and we're going to solve the inequality. G is less than 0. So here's, I want the graph. Less than means I want it to be below. The 0 is telling me I want it below the x-axis. I first figure out where it's equal to 0. So that's at 0 and 4. The pieces that are below the x-axis are these tail ends here. So how am I going to write these intervals? Okay. And actually on this one I'm going to write it with the inequality first and see if that helps us write the interval. These x values, they start at 4, and these x values keep going to the right, so they get bigger. So x is greater than 4 here. On this side, the x values are at 0, but they're going down and left means they are smaller than 0. As an interval then, it's negative infinity to 0. I'm not including it. Along with 4 to infinity. It's a different way for looking at these. In class, we're going to talk about how I could do this without the graph. Your assignment is to look at the graphs on the worksheet and state the intervals where it's greater than 0. There's also a little bit of review of compound inequalities. So if you have any questions, come in early, go ahead and email us, let us know where we can start to help you out, and we'll talk to you later. Thanks.